Now we are starting this part of the video, which is after the private part. And here in the private part of the video, I described what I have inside, in fact, test_6.vhd, the top level file. I described the blocks that I have instantiated inside the top level module for partial reconfiguration, and then I described a little bit about the steps that we should take to define, in fact, partitions for our design, and then to define, in fact, logic lock regions for our design. So these topics are covered inside a private video. You can watch that to learn more about them. And now we are in a phase of our project that we want to define, in fact, different personas for the blinker module. So far, the blinker module has only one persona. So if we look at files, the implementation that we have for the blinker module is this one. This is the only implementation that we have for this module, okay? But this is a kind of module for which we have several implementations, and now we are in a step that we want to introduce those other implementations to the Quartus software, okay? So we want to tell the Quartus software, look, this blinker module has also these other implementations, okay? And then later we will use, in fact, each of these cases to generate the suitable betastream for partial reconfiguration for that persona. Okay, so I want to add a new revision to this project, and in that revision I will remove this file and I will add the file related to the second implementation or persona of this blinker module. Okay, so if we look here at the tabs that this software has, the Quartus has, in the last tab we see the revisions. Okay, and right now there's only one revision for our project, and that is test_06. This is the main revision of our project. Okay, now if you want to introduce a new persona for one or some of the modules that you have inside your design, for each of those guys you need to define, or you need to create a new revision. So I right click here and then I select create reconfigurable revision, okay, and then I give my revision a name. For example, I will call it test6 persona 2. Okay, so I have test6 persona 2. This is a new revision. I have this revision, and by double clicking on the revision you can make it active. Okay, and now that this revision is active, you come back to the files tab, and inside the files tab you remove, in fact, the current implementation that you have for the blinker module. So remove file from project, and instead you will add for this revision the new implementation that, or the new persona for this blinker module. So I come to as to project, then I would select persona 2. I will add persona 2. I will apply, I will press OK, and now for the blinker module I have a new implementation. So if I come back to the revision tab, if I enable the main revision, if I look at the files, I will see that for this revision the active or implementation is persona 1. Okay, and if I enable persona 2 revision, then I come back to the files inside the design, I would see that the implementation is persona 2. Okay, and the same thing I should do for the next persona of the blinker module. So again, I will right click, create reconfigurable revision. I will call it test_06 persona 3. Okay, and this is a new revision. We add it to the design, And basically what Quartus is doing is copying all of the files from this revision to here. Okay, so I enable this revision, I make it active, and then I come back and I will change what really differs between persona tree and the main in fact revision. So this one I don't need it, and I add in project tab, add, and then here in the source I would add persona tree here and here. Okay, so we have right now 3 revisions basically, and each revision contains a suitable persona for the blinker module. Now the next step, I should generate in fact the beta streams for each of these revisions. Okay, but before doing that, so imagine my current active revision is this test 06 persona 2. Before I go ahead and I go through placement, synthesis, and then generation of the programming file, what I should do is that I should tell Quartus that for this revision, what is the source for the partitions that our design has. So if you have watched the private video, you know that we have defined some partitions for our design. So the partitions that we defined for our design, we can see inside the design partitions window. So right now, if I enable the main revision, for inside the design partitions window, you would see, in fact, a netlist type is post synthesis. Okay. If I enable any of those 2 revisions, this field cannot be empty. In fact, you should tell Quartus that for these 2 partitions, in fact, we have a design. We have something which is our implementation. Okay. So I'm telling that Quartus go and look at my source code and synthesize and compile my source code for blinker module as the source of this partition. Okay, and the same thing I should do also for the partitions that I have inside persona 3. Okay, so persona 1 partitions, persona 2, persona 3. Okay, now we go ahead with the generation of the programming files. Okay, this is a small error that happens when you try to, in fact, generate the programming file for each of your revisions before the main revision. So this is a mistake I have made here. So I enable the main revision, and for first you need to generate the programming file for the main revision and then the others. Okay, so I enable the main revision, and now I go ahead and generate the programming file for this one. Okay, so now for the main revision, we have generated the programming file successfully. Again, I enable the next revision and generate the programming file. Okay, now we have the programming file generated for the, in fact, second revision, and this is basically for both of the blinker modules, we have the same logic. Okay, so we have that static blinker in the top level, and then for both of the blinker modules we have the same logic. Okay, this I have described before. And now I enable the third revision of our design, and I go ahead with generate programming file. Okay, and finally we have the betastream for the third implementation. Okay, and now here comes the tricky part of our project, and that is to generate the partial reconfiguration betastreams. So far I have generated 3 betastreams, but these betastreams, they are for the whole design. They are not for just one specific block. Okay, and now it's the time to generate, in fact, 6 partial reconfiguration betastreams. 3 for each of the blinker modules, for each of their 3 personas. Okay, you can do that either through a set of command prompt or shell commands, which is the most convenient, or you can do it using the GUI that the Quartus is providing to you. And for now I do it using the GUI. It's a little bit boring. So inside the files menu, there is a menu convert programming file, and through this you can generate the partial reconfiguration betastreams that you need for your design. Generation of partial reconfiguration betastream is done into 2 steps. First, you should, for each of your partial reconfiguration betastreams, you should generate the partial masked SRAM object file, and then after you generated the partial masked SRAM object files for each partial reconfiguration betastream, then you need to generate raw binary file for partial reconfiguration, the .rbf file. Okay, so for our design we have 2 modules, each one 3 personas, so total we have 6 .pmsf files, and then later we will have 6 .rbf files. Okay, so I start with generating these .pms files, and for generating each .pmsf file you have 2 inputs. The first one is the betastream for the design which contains that persona. Okay, so for example, imagine I want to create the area 1 persona 1 .pms file. Okay, I want to generate this file. Okay, so this is for the first blinker module, blinker ins, and I want it to have, in fact, persona 1. So this is the file that I want to use for generating the partial reconfiguration betastream for blinker module, the first blinker module with persona 1. Okay, so this is the name of the file. The inputs that I need to give the tool to generate this file are obviously 2 inputs. First, a betastream which contains persona 1 for this module. Second, the mask for that area that the blinker 1 module is residing. Okay, so for the MSF file I will give, in fact, this mask, because we want to create the file for persona 1. So if you look at the files that Quartus has generated, Quartus has generated 2 files for these 2 blinker modules for persona 1, 2 files for blinker modules for persona 2, 2 files for 2 blinker modules for persona 3. Okay, so for now I have blinker 1 persona 1, which is corresponding to this file. Okay, I select this one, and then for SOF file I select this one. This is the betastream, in fact, for the design with blinker modules having persona 1. Okay, so I select this one, and this is the output. These are the inputs. I press generate. Okay, and the file gets generated. I continue this procedure for the rest of the guys. Okay, so I have created, in fact, if we look here at the output files, I have created the files that I need. All of the 6.pmsf files that I need, okay, for area 1 and for area 2. And now it's the time to generate the final partial reconfiguration betastream file. Okay, so I come here, I select raw binary file for partial reconfiguration, and then the naming is kind of similar to the previous one. So we will have area 1, persona 1, and this one is very simple. You have only one input file, .pmsf, so I would say add file. And so for area 1, persona 1, I have area 1, persona 1.pmsf, and I would add this one here. And then there are a set of options, properties here. You can do compression on the partial betastream file. You can enable this scrub or and/or, it's by default and/or mode, or you can enable scrub mode. And then for the memory blocks, you can write memory content. I don't have any of these guys at the moment. So this is the input file. This is the output file. We press the generate button. And then we have our first partial betastream ready. I continue area 1, persona 2. So here remove the file, select add file, output area 1 persona 2. So generate. Okay, this one is also done. Here is the result. We have .pmsf file, and then we have RBF file. And what's the size of RBF file? It's 1.1 megabytes. Yes, and this is the output files folder. Okay, so all of the output files from our flow. This is test 6 folder, output files. And then if I scroll down, these are the .msf files that we talked about. And if I scroll down, I would see the .sof file. So here is one of those .sof files. What is the size of .sof file? It is 6 megabytes. Okay, so the file which contains the entire, in fact, configuration information of your FPGA, it has a size of 6 megabytes. Okay, and the file that contains only some partial configuration information, its size is only 1.1 megabytes. Okay, it's smaller. And then I think the SOF probably has compression enabled, and this one doesn't have the compression enabled. So if I enable the compression, its size should be smaller. Okay, so we have generated these files, and now it's the time to actually test these betastreams over the board. So what I would do is I prepare the board, and then we test the betastreams to see if it is working or not. Okay, so here this one I close, and then we will need our programmer. I open up the programmer interface, and previously I have loaded the required drivers, and the JTAG daemon of Altera is running. So hardware setup, and then inside the hardware setup I select socket, and then I have the socket. So I say auto detect, and I select my device, and so I have, in fact, the components inside the JTAG chain of socket, which is the FPGA fabric, and then the processing system, which is the ARM subsystem. Okay, and now what I want to do first, I try the normal betastream files, and then I use the partial reconfiguration betastream files to see if they are working or they are not working. Okay, so here I would say change file and then output files and then test underline 6.sof. This is where both of the blinker units, they have persona 1. Okay, so open, and then I want to in fact configure the device and then start. Okay, so the device gets programmed and I have the camera in front of my circuit board, and you can see how do the LEDs look like. As you see, we have 3 LEDs, and all of the 3 LEDs are blinking at a similar frequency. The LED 1 is here, LED 2 is here, and LED 3 is here. LED connected to the static logic, and LED 2 is connected to blinker, the first blinker. LED 3 is connected to the second blinker, and as you see, they have the same clock frequency. And I have in fact the reset button here on one of the push buttons that I can, if I press the reset button, I can make them synchronize, or better to say, they will start from a known state. And this is kind of important when you do partial reconfiguration, because when you partially reconfigure a unit, obviously after that you need to apply a reset to that unit so that it starts from your known state. Okay, so here is the reset button. Okay, now I can in fact program my device with another betastream, change file, persona 2, and practically what happens right now is that with persona 2, if I program the device, what we will see for persona 2 is that right now the first LED, which belongs to the static logic, is always blinking at the same frequency, right? So it's blinking at the same frequency as the previous time, and the other 2, which are the blinker units, they are blinking at a lower frequency. So far we have not done any partial reconfiguration. And now I want to load in fact my first partial betastream. So right now what we see is that LED 2 and LED 3, they are blinking with a frequency defined in persona 2. Yes. So what I want to do is I want LED 2 to blink at the same frequency as LED 1. Okay. So in order to do that, I should load a partial reconfiguration betastream, one of my partial reconfiguration betastreams. So I come here, add PR programming file, and I want to program in fact the first blinker unit with persona 1. Okay, so I select this one, I press open, and now I want to program this RBF file. Yes, this partial reconfiguration betastream file. So I press start. Okay, it gets programmed into the device, and here you see the result. Okay, and now if you look, the first LED and the second LED, they are blinking at the same clock at the same frequency, and the third LED is blinking at a lower frequency. So let me apply the reset so that you can see this in a better way. Yes, so the reset is playing here an important role because it's indicating the starting state of each of these counters. Okay, so here with partial reconfiguration, I changed the persona of the first blinker to persona 1 while having blinker 2 running at the same state as before. Now imagine that for LED 3 for blinker 2, I want to lower the blinking frequency. So for blinker 2, I want to in fact program the blinker 2 partially with the betastream of persona 3. Okay, so change PR programming file, blinker 2, persona 3, open, and then start. Let me double check here. Yes, start. So this is now programmed into the device. What I expect to see is that LED 3 is now blinking at half blinking frequency than before. So this is now programmed into the device. What I expect to see is that LED 3 is now blinking at half blinking frequency than before. Okay, and now as the final test for LED 2, let's program blinker 1, which is connected to LED 2, with a partial betastream file of persona 3, so that LED 2 and LED 3 blink at the same clock frequency. Okay, so here I would change PR programming file. So for blinker 1, I want to load persona 3. So blinker 1, persona 3, and then start. So now I expect that these two guys, LED 2 and LED 3, blink at the same clock frequency. I just apply the reset to make the states similar to each other. Okay. So the first LED is always blinking at the same clock frequency as before. It's our static logic, and as you see, with partial reconfiguration, I'm able to partially program each of my blinker units. Okay, that's the end of this lesson. I hope you enjoyed it, and soon I will continue with the next lesson, in which we don't use the JTAG cable, but we use the ARM host located inside the SOC device to transfer the partial reconfiguration betastream to our FPGA fabric. Thanks for watching. Bye.